The curve in figure 5 shows the way in which the gravitational potential energy of a body of mass m in the field of the Earth depends on r, the distance from the center of the Earth for values of r greater than the radius of the Earth. So this is the potential energy curve. What does the gradient of the tangent to the curve at r equals to r represent? So this is a tangent at this point. So the force is equal to minus du dr, where u is the energy, the potential energy, and r is the distance. So the gradient represents the gravitational force at r equal to re. A positive gradient represents a negative force, which means the force points towards the center of the Earth. In other words, a positive gradient indicates an attractive force. The body referred to above is a rocket, which is projected vertically upwards from the Earth. So it's projected vertically upwards and then come back down. At a certain distance r from the center of the Earth, the total energy of the rocket, that is gravitational potential energy plus its kinetic energy, may be represented by a point on the line PQ. 5 points A, B, C, D, and E have been marked on this line. Which point or points could represent the total energy of the rocket if it were momentarily at rest at the top of its trajectory? So the total energy equals potential energy when the rocket is momentarily at rest. So when it's at rest, the kinetic energy is 0. So the answer is B. So this is the point. Which point or points could represent the total energy of the rocket if it were falling towards the Earth? So the total energy equals potential energy plus kinetic energy. So when it's falling towards the Earth, the kinetic energy is positive. So the total energy will be less negative than potential energy. So answer is C. Which point or points could represent the total energy of the rocket if it were moving away from the Earth with sufficient energy to reach an infinite distance? Total energy equals potential energy plus kinetic energy. Potential energy is 0 at infinity. Therefore, kinetic energy equals total energy at infinity. In order to reach infinity, the kinetic energy and therefore the total energy must be equal or greater than 0 at infinity. Since the total energy is a constant, it must be equal or greater than 0 at all points. If it's greater than 0 at infinity, it must be greater than 0 at all points. So the answer is D or E. So D is when the total energy is 0, or E is when the total energy is greater than 0.